So for today, I have these two flow charts that you do have access to on It's Learning. So I'll show you where those are. But the reason why we're making flowchart, or we have flowcharts, is because if we were in class together right now, we would be making little flip charts with all of these names. And then you get to use the flip charts to help you and figure out how to do all this. But since we are not in person, we have these flow charts instead, because you need to ask yourself these questions. So these flow charts help you to get what we've been doing the last couple days down, because before we had it in compartments of ionic compounds and then molecular and then acids. But after, like from here on out, they're all going to be mixed together, and you have to identify the type of compound something is in order for you to correctly write the name of it or write the formula of it. So just to show you where these are located before we get started talking about them. So it's up to you if you would like to, you can write your own down, but there is a copy for you to print off if you want it. So today's assignment, the I-A-N-M compounds, this is what you're going to use it for that, and you're going to use it for the quiz that's coming on Friday, okay? But on the chapter 9 page, where you're watching your note videos, hopefully, under paper resources, I've added another folder called flowcharts, and these two flowcharts right here are the two flowcharts that we're going to see in class today, okay? And I think I have them as nice as they're going to get, but we'll see if I can think of any improvements during this class that we still don't have. So I may update them. Like I put up what I had by the end of first hour, and then I've been improving it. So once I'm all set, I'm going to send out a remind message to everyone that says, this is the most updated. It's all set to go. I'm not going to make any more changes. So if you would like to print this off, you can. Or if you don't have a printer, you can write your own down, and you can color code it or whatever you want to do with it. But these are questions that you need to ask yourself when you are writing a formula or when you're writing a compound name. And you need to think in this process to do it correctly, okay? So this is what's going to help you with that. So let's first start with writing a compound name, because that's what I have pulled up. If at any time you have any questions, go ahead and type them in the chat, or if you don't understand something, let me know so I can help you. Somebody else might have the same question. So what I mean by writing a compound name, okay, you are given the formula first. So like, let's say that you're given, and I can't make the subscripts, but let's say that we have Na2SO4. Right, so just envision that the 2 is small and that the 4 is small, okay? So to write the formula, we do it best if we first figure out the type of compound that it is, and then from the type to determine its name, okay? So these questions help us with that. So I'm just going to walk you through the whole thing, and then we'll come back to figuring out for Na2SO4, and we'll do a couple other examples as well. I don't have anywhere that these examples are coming from. I'm just pulling them off the top of my head to show you how it's used, okay? So the first question you ask yourself when you're looking at the formula, are there more than 2 elements? This is going to help us determine if we have a polyatomic ion or not. So when I ask more than 2 elements, I'm not necessarily looking at the subscripts right now. I'm more looking at the unique different element symbols. So like in this one, we have sodium, we have sulfur, and we have oxygen. Since that is more than 2 unique different elements, then that means that we have a polyatomic ion. And so then we would need to look at the polyatomic ion sheet, the sheet right here, for what we're dealing with. Okay, so if we know that we have more than 3 elements, then that means that we will need to look there for something. Okay, then after we figure out if we have the polyatomic ion or not, then this is where we start figuring out what type of compound it is to name it correctly. So the next question is H in the compound formula. Is it first? If H is first, then that means the type of compound that it is an acid. That is a direct way to tell that it is an acid when you have that cation is hydrogen, okay? This example doesn't have that, but if we have hydrogen first, then we use the table, which I've included it here for you, to help you determine the name. And so this is where, if we know we have the polyatomic ion and we know what that name is, that helps with using this table. But it's the same thing as what we did before, where you would insert the root of the element name into the blank to come up with the name, okay? So that just ends it there if you have an acid. But if you don't have H first in the compound formula, then the next way to determine whether it's ionic or molecular, 99% of the time, is if it has a metal. So not only do you need to have those polyatomic ions handy and you need to have this flowchart handy, you also need to have your periodic table handy. So just a refresher, metals are on the left side, non-metals are on the right side. So we have a lot of metals to choose from. If you have an element from the left of the stair step line, then that means that it is an ionic formula or an ionic compound. So then you use the name of the cation. So like if it is sodium, you use sodium, or if it's ammonium, use ammonium. But then the second part, you use the polyatomic ion name or change it to IDE if it's from the periodic table, okay? And if it's ionic, just be careful of the Roman numerals. And the 5 elements that could contain a Roman numeral are copper, tin, iron, nickel, and lead. And I'm being nice and I'm giving you that information, okay? So that would be how you would figure out the name if it is ionic, all because it has metal, okay? If it does not contain a metal, so if it only has 2 elements and they're from the non-metal section, then that means the type of compound is molecular. And so the prefixes tell how many, and I've included the prefixes so that you know how many there are. And with that, just know that you also have to change the ending to IDE. So like instead of oxygen, you would say oxide, just like we would if it was ionic. But I just put that little note in there to help you out. Okay, so if you ask yourselves these questions and you go through the flow chart all the way down, then you should have no problem and you should do it correctly. So going back to the Na2SO4, see how this works, okay? First question, are there more than 2 elements? I did say yes before. We have sodium, we have sulfur, we have oxygen. So that means that we have a polyatomic ion. So if we look at the polyatomic ion list, SO4 is called sulfate. So that means we're just going to use the word sulfate if it is not an acid. If it is an acid, we have to change it, but we'll see. So the type of compound, we don't know yet, but I'm just going to write it down for now that we have sulfate so that I don't forget, okay? Next, after we know that we have a polyatomic ion, the next question is hydrogen first in the formula. No, it is not. So then, is there a metal? Sodium is on the left side. So yes, we do have a metal, which means that the type of compound is ionic. And so then to name it, we just use the name of the cation and the name of the anion, being careful of Roman numerals. We do not need a Roman numeral because sodium isn't one of those. So the name is just going to be sodium sulfate because the anion is that sulfate polyatomic ion, like so. Okay, so to do it correctly, because a lot of times, and I unfortunately did not have enough time this morning before school to grade your ionic compounds worksheets, but if it's anything like my regular classes, like 95% of people miss the same 7 questions because they just Googled to find the answers. So I'm going to be grading yours during 4th period, and if that is the case, I will send out a message and If you contact me, then I'll let you redo it for better points, because Google tells you things wrong. Like number 9, a lot of people write trisodium phosphate, and that is not right, because if you have sodium, it's an ionic compound, and you do not use the prefixes, okay? So this is why we need to follow the steps. So let's do another one. Let's go with, I'm just gonna make this off the top of my head, looking at something that's old. Let's try like CF4, so that's a little 4, okay? We need to figure out the type of compound to help us figure out the correct name. So, first question, are there more than 2 elements? We've got carbon, we've got fluorine. No, we've only got 2. So that means that both of the elements are coming from the periodic table, no polyatomic ion included. Next question, is hydrogen first in the formula? No, we do not have hydrogen at all. So it's not an acid. Is there a metal? Looking at the periodic table, carbon is on the right side, and so is fluorine. So that means that no, we do not have a metal. So that means if there's a no, our type of compound is molecular. And so to do a molecular name, we use the prefixes to tell how many, with the second name changing to IDE ending. Now, I didn't include this on here because I want you to know this yourself, but remember, like we only use mono for the second part, not on the first element. So we're not going to say monocarbon, we're just going to say carbon, because that is an implication that there's one. So the first part of the name will be carbon. And then we have 4 fluorines, so we will say tetrafluoride. So carbon tetrafluoride is the correct name for CF4. All right, let's go with one example with an acid, just so you see how it works, okay? Do you guys, did you guys, is this making sense to you? Is this, like, is it helpful to have this kind of thing, hopefully? Let's do, H3PO3. So again, just know that those 3s are little, okay? So first question, are there more than 2 elements? Yes, we have hydrogen, we have phosphorus, we have oxygen. So that means that we have a polyatomic ion. So Jenna just asked, and I want to stop and just say this, you use the IDE ending when it is the second part and it doesn't have the polyatomic ion name. So if you have a polyatomic ion name like nitrate or sulfate or something like that, then you would just keep the name as is from that sheet, that list. But when it's ionic or molecular and it just comes from the periodic table, like we just did fluoride, okay? If it's second in the compound, then that's when you change it to IDE. So if it's from the periodic table and it's second in the formula, then you would change it to IDE. That's a good question. Good question. Okay, back to this, sorry. We're gonna look for the polyatomic ion name because we've got 3 elements, okay? So looking for the PO3, and that is number 19, phosphite, PO3 -3. We may or may not use phosphite, but I'm going to write it down just so that I remember. Just so that I remember what to do. Okay, good. So I'm just going to put phosphite up here so that I don't forget it, because I probably will, because I have to flip through all these things. Okay, so then after we figured out it's a polyatomic ion, now is hydrogen first in the compound formula? Yes, it is. So yes, since it's in the front, the H is in the front, then that means that the type of compound is acid. And so we're going to use the table to determine the name from the part from the anion. So that's why it's good that I wrote down phosphite, right? Because the ITE ending will help us to know what to do about the name. So since it's ITE, we will take off the end and add OUS to the base. Now, if you do it like phos like that, acid, I'm not going to count that wrong, but phosphorus is special like sulfur. And I think I mentioned this yesterday and in the video, but phosphorus, you don't just use phosp as the base, you actually use phosphor. So it's actually called phosphorus acid. And that is what the H3PO3 stands for. Okay, so we've gone through examples of each of the branches to know how to use this writing a compound name. Okay. Do we have any questions about that right now? Otherwise, I will move over to how do you write the formula when you have the name, sort of thing. So I'll just pause for a second in case you have any questions. All right, so if you still have any questions, just make sure you ask them. But let's just look at the formula writing chart now. So it's similar, it has a lot of the same information, but it's just going in a different way because this time we're going to be given the name first and we have to produce what the formula is. So this time we would have been given the phosphorus acid and we have to produce the H3PO3, okay? So with the way that this works, the first question to ask yourself will actually help you identify the type of compound right away. And it's really important to know the type of compound because if it's molecular, we don't use charges to write the formula. We do use charges if it's an acid or if it's ionic, but we don't if it's molecular. And if you do use them when it's molecular, you will do it wrong, okay? So the first question, does the name contain a prefix or the word acid? If it has a prefix, then that automatically means that the type of compound is a molecular compound. And so you're going to have prefixes in there. The prefixes tell how many. So you would just tell, like, you know, we had CF4. So that's what we do. It's pretty straightforward, pretty simple. It's really nice when it's molecular. If it has the word acid in it, then that tells us the type of compound is an acid. It's very nice that you see the word acid to know that the type of compound is an acid. So to write the compound, the H plus is the cation to start it. And then the name from the acid, we use this table to help determine what is that cation, because once you know what the cation and anion are, sorry, you know what the anion is based on this, then you need to balance the charges to write the formula, okay? If it is not a prefix, if it doesn't have a prefix, if it doesn't have the word acid, then that means that it is an ionic compound. And so with the ionic compound, eventually, yes, we do need to balance the charges, but we have to be careful about where do those charges come from. So the next series of questions helps with that. So once you determine it's an ionic compound, you have to know, does it have a polyatomic ion? If it does, there's more than 2 elements, so you need the formula from the list of polyatomic ions. And you would know that from the name, like if you had nitrite, or if you had hydroxide, or one of those names from the list, that's how you would determine if it has a polyatomic ion. If it does not have one of the names from the list, that means that it probably has that IDE ending for the second element. And so the periodic table will give you what the charges are from, usually from the column numbers. Remember, we wrote those down at the top. Okay. And then last but not least, if the name has Roman numerals, which I don't have it on here, but it's on the other one, and it would be like copper 2 right away. So you would see that. The Roman numeral tells you the charge of the cation, not how many there are necessarily. That was one thing I noticed was wrong on a lot of kids' papers that I've graded so far too. If it was like copper 2, they would say Cu subscript 2. And that's not necessarily correct. So the Roman numeral tells you the charge. But if it doesn't have a Roman numeral, then that means that it's probably from like 1A or 2A or 3A. And so +1, +2, or +3 would be its charge. Okay, so you just have to be careful with that. And then just like with acids, you have to balance the charges to 0 to make a neutral compound for it to be written correctly. All right, so let's do some examples of writing formulas so that we know what we're doing. Nope, I'm not going to share my screen. Let's just write like we've been doing. That makes it a lot easier than flipping through all the time. So let's say that you're given the name dihydrogen monoxide. Dihydrogen monoxide. Okay, so first question from the name, does the name contain a prefix or acid? It doesn't have the word acid, so that's a no. But it has di and it has mono. So those are both prefixes, so that means that the type of compound is molecular. All right, so then to write the formula, we just use the prefixes to tell how many. So I'm gonna run over to my TV to write, because if I write with my mouse, it's horrible. So for the dihydrogen, that means we have 2 H's, each 2, and monoxide means 1 oxygen. So H2O is the formula for dihydrogen monoxide. I hope on the molecular compounds worksheet that you turned in yesterday, you put dihydrogen monoxide. If you put water, if any of the kids who are not joining on Zoom put water, I get a big fat -1 point. So that's how it would work if it was for molecular. Let's do another one. Let's go with, let's say that we have copper 2 nitrate, copper 2 nitrate. Okay, so question number 1, does the name contain a prefix or acid? There are no prefixes and there's no acid. So that means that it is ion. So we're going to need charges to balance the 0. Does the compound have a polyatomic ion? Yes, it does, because, hint, hint, we have an ATE ending. So if we look over at the polyatomic ion list, nitrate is NO3 -1. So we are going to use the NO3 -1. I'm going to write that down so I don't forget. And then last but not least, the last question, does it contain Roman numerals? And yes, it does. So the Roman numeral tells the charge. So when it's copper 2, that means that you have Cu with a +2 charge. There will not be 2 coppers in this formula. Okay, so now we need to balance the charges to write the formula to get to the end. So I'm going to teach you, I'm just going to review what you were taught at the beginning, but then very similarly to the way that I was trying to show you the shortcut to figure out the number of H's for the acids yesterday, you could do that with any charge balancing at all, okay? So just so we look, remember we want the charges here to add up to 0. Right now we have a +2 and a -1, so they don't. We need more negative to make it equal 0. So that means that we would need another NO3 -1. So that makes us have an overall -2 to balance out that +2. So the correct formula for this would be Cu, and then, so we have 2 NO3 groups, so we have NO3 inside parentheses, and then a 2 on the outside, like so. So that is the correct answer for the formula of this one. Now, I'm going to show you how to get the same formula doing it a faster way. So if we look at the original, let me just, oh, I erased everything, sorry. So we had copper with a +2 and nitrate with a -1. Okay. Remember yesterday I said that when you have whatever the charge is here, that becomes how many H's you have in your formula. It works for ionic compounds too. So since there's a 1, that means that the subscript on the Cu is going to be a 1. The same thing can apply for the copper, the first part. Since we have a +2, that tells me that the subscript on the NO3 is going to be a 2. So the correct answer, we have Cu1, which you don't have to draw the 1, right? But then this is a group that stays together. So nitrate stays grouped together by parentheses, and then the 2 goes on the outside. And you get the same exact answer as we did with the counting of all the charges. So the -1 charge came from this list where nitrate had a -1 right here. So that's how I knew that we had a -1 on the nitrate. And then the +2 comes from the word was copper 2. So that Roman numeral tells us what the charge of copper is. So that's where I got those charges from. Okay. But if we had like, I don't want this to get too confusing, so I'm going to erase really fast. Let me clear everything. Let's say that we had just like sodium oxide, okay, as our thing that we're trying to write the formula of, sodium oxide. So this one is going to be ionic because it doesn't have the word acid, it doesn't have the prefix, but it does not contain any polyatomic ions, and it does not contain any Roman numerals. So when it has a no for both of those, then that means that the charges are just going to come from the periodic table for each of those. Okay, so that's where like we look at what columns they're in. So like sodium is in the first column, so that has a +1 written above it, and then oxygen is in 6A, so that has a -1 charge. And so if it doesn't have a polyatomic ion and it doesn't have a Roman numeral, then that means you just look back at what we originally wrote on our periodic tables. Okay, so then for sodium oxide, we've got Na has +1 charge and O has a -2. So if we think about that whole like crossing thing, then since there's 1, that means the O will have a subscript of 1, and then the 2 will be the subscript on the Na. So the formula for sodium oxide is Na2O1, like that. Good question. Do we have any other questions right now about this? Or do you find that this is pretty helpful? So again, in case you weren't here or you've forgotten, you don't have, if like the video is here to help you explain how to use it. You can write it out yourself if you want to make it all fancy and colorful or whatever. But if you would like to just see the copies that I've been using, on the Chapter 9 page, under Paper Resources, there's a folder that's called Flowcharts. And I've got both of them there. And so you can download those, you can print those off, or just look at them, whatever you need, okay? So those are both there. Last but not least, so just to show you what the assignment for today looks like, you do have multiple opportunities to get a correct score, and it will tell you right away when you get something wrong. But so sometimes the questions will ask you to tell me what the correct answer is, and so you have to use the flowchart to help with that. Sometimes you will have to tell me what the name is. Sometimes you have to like tell me what the type of compound is, sort of thing. So you would drag it all over. But like for this question, when I ask you for the name, it does not ask you to tell me the type of compound. But if you don't know the type of compound, you may not name it correctly. So that's why it's still important to go through those steps to work it out for yourself. Okay, so this is the assignment for today, and I'm not going to do any with you. I want you to just try it yourself. But if you have questions, you can stay on and ask. Otherwise, that's all I've got planned for today. So you can go ahead and leave if you want to. And I will post this recording on It's Learning as well in case you need some help or want to review over it.